All right, guys, we are going to add some more to our notebook, and today we're going to talk about some new angle pairs. So in our table of contents here, um, we're now going to add some new angle pairs. And we'll do that on 31 and 32. Okay, so here we go, 31 and 32. I'm pretty sure the next notes that you have in your packet are the right ones. I think they should be in the right order. So you're looking at something like this. This one we're going to fold in half like a book, stuff on the inside, and then we'll put that on 31. And then the next one we need as well. So it looks like this one here, maybe you're looking at this side. But either way, we're going to want to turn that over and look here and fold these two in to meet in the middle. And that will go on 32. And if you want to cut out these little dash lines to get some doors, you can totally do that. All cute stuff. Gosh, I was having a struggle moment there. Let's get some tape here. Okay, so before we jump into our new angle pairs, I actually want to talk about planes again a little bit. So I know we've been dealing with a lot of lines on the coordinate grid, like how to graph lines, how to write equations of a line, and parallel and perpendicular lines on the coordinate grid. We're actually going to leave the coordinate grid again and just look at lines on like a plane. But before we get into the line part of it, I want to talk about the plane part of it. So this might be a tricky drawing to make, but I'm going to try to make like a little 3D shape here. So do your best to try to make one as well. Normally what I do is I draw a square and then put the square back off of it and then just connect all the corners. I feel like you guys have tried this before. Now on each of the corners, I'm going to want to put a letter so that we can talk about all the different planes here. So we got A, B, C, D, E, and then H. And I think I got all the corners labeled. Super. So when I have a plane like this, we can also have things that are parallel or perpendicular or neither. Okay, so in this plane here, we could say that planes are parallel when they don't intersect each other. But are also going in the same direction. It's so hard to explain. Going in the same direction. So an example of that could be, we could say the top and the bottom. So those are parallel to each other because they won't intersect and they're like in the same direction because they're both like flat. They're both kind of horizontal. We could also say that the front and the back planes are parallel to each other because they won't cross and they're kind of going in the same direction, like both up and down, like vertical. We wouldn't want to say that like the front plane and then this side plane are parallel because they do cross, they intersect on CD. So those wouldn't be parallel. So an example of some parallel planes, we could say plane, let's say the bottom one, ADE, is parallel to plane. So that's the bottom. The top, we could describe as GCF. Oh, math joke, GCF, Grace comment back here. Anyways, so maybe let's get some color going on here with some highlighters. This guy, my yellow plane is the bottom. Man, that highlighter is just dead. And then this plane here is the top. And so those would be some parallel planes because they're kind of both horizontal, laying flat and not going to cross each other. And yeah, we only need to name them with 3 points because 3 points make a plane. Now, planes could also be perpendicular. When they intersect at a 90-degree angle, just like we do with lines. This is just a bigger figure that we're looking at here. So for instance, if we're looking at the bottom again, if I go with the back plane, those two cross at a 90 along line HE. So like if you think about a room, right? The floor and a wall need to intersect at a 90-degree angle. Otherwise, I feel like your room's going to fall in. So an example of some perpendicular planes could be plane ADE again. The bottom is perpendicular to plane. Let's see, can we make anything clever? Not really. Half, I guess, is the best we can do. And that is that back plane. Now we could also say that the top is perpendicular to the back. So we could also do that one. That would be fine as well. Now, last but not least, we might be something that's called skew, which is like not parallel or perpendicular. So in this drawing here, you can't really see a skew thing. You could talk about a plane and a line being skew, and that would be a better example that I can show you in this picture. So you can be skew if you are neither. So if you aren't parallel or perpendicular, you might be skew, or you're probably skew. And again, that's hard to do with 2 planes in this picture because in this picture, the planes are either parallel or perpendicular. But if I talk about a plane with a line, then we can see what skew means. So we could say that plane, HEF, so that back plane, is skew, and like there's no fun symbol for skew, unfortunately. But that would be like skew with line AD. And that's because like this plane back here and this line right here, they're not going to intersect each other perpendicularly, and they're not going to be parallel either because it's like a plane and a line. Oh my gosh, it kind of doesn't make sense. But in some of the pictures that you're going to see in the homework, I think you'll understand better what skew is. They're just like not parallel to each other, and they're not going to intersect each other perpendicularly either. Like maybe they're crossing at a weird angle, so it's neither and not both. Okay, so that's kind of that. We also need to talk about multiple lines. So again, not lines on a coordinate grid anymore, lines on just a blank plane. And when I have 2 lines, not necessarily parallel, but then those 2 lines are intersected by a 3rd line, that line there has a special name. So when a line intersects 2 other lines, we call that line a transversal. And when that happens, and I mean this happens with all lines that intersect each other, what you get are a bunch of angles. So when we were looking at it before, when we talked about some of our angle pairs, we just had 2 lines intersecting. We could talk about those vertical angles that we get right here and right here. Or we could talk about linear pairs, which are angles adjacent and supplementary. So we have lots of those. So when we get 2 lines crossing each other, we get 4 angles. Now, when I have 2 lines that are being intersected by this transversal line, I really get 8 angles now. So I have the 4 at the top, but I also have these 4 down here. So if we call this 1, 2, 3, 4, and then 5, 6, 7, 8, we can talk about some new angle pairs, okay? So when we need to talk about these angle pairs, we are comparing one angle at the top intersection to a different angle at the bottom of the intersection, or at the bottom intersection, okay? And we can relate that in one of two ways. You might be on the interior, so this is kind of the interior of the two lines intersecting, or you might be on the exterior, which is like outside of the two lines intersecting. So interior is inside the two lines intersecting, exterior is out. We can also make a comparison between being on the same side of the transversal. So like 1, 4, 5, and 8 are all on the same side of the transversal. Or we can talk about being on alternate sides of the transversal. So like 1 and 2 are on alternate sides. Okay. 1 and 2 are a pair that we already know. Those are a linear pair, but now we're looking at these new pairs where we compare this top intersection to the bottom intersection. Okay, so hopefully you guys made a good guess when we tried the Desmos activity earlier. And now we have our angle pairs over here. So we have our interior ones and our exterior ones. So again, interior angles would be all these ones in here. Exterior angles are all the ones out here. And so when we're talking about interior angles, we could specifically talk about interior angles that are alternate of each other, so on opposite sides. So 3 and 5 would be a pair of alternate interior angles. 4 and 6 would be a different pair of alternate interior angles. Okay. Now, similarly over here with our exterior angles, since we're talking about the outside angles, we can be alternate as well. So if I pick angle 1, the one that is alternate to it and exterior down here would be 7. Okay, so I have to be on the outside and I have to be on the alternate side of the transversal. We also have another alternate exterior pair, and that would be 2 and 8. Now, we can also have same side angles, which another word for same side is consecutive. I always like to just say same side because it's a little bit more descript, but consecutive means the same thing. So same side interior angles would be angles that are on the inside and then on the same side of the transversal. So a pair of those could be like 3 and 6 because they are inside and on the same side. We also have the pair 4 and 5. Now we could also talk about consecutive exterior angles. We just don't use those as often, but consecutive exterior angles would be a pair like 2 and 7 or 1 and 8 because they're on the same side but on the outside. So those are consecutive exterior angles. Now last but not least, corresponding angles are kind of the weirdest ones, but they're very useful. So corresponding angles are angles that are in the same position compared to top and bottom. So in the same position. So, for example, if I were to pick angle 1 at the top intersection, that is on the left side of the transversal and above line M. So down here, between the second intersection at the bottom, I need to pick one that is to the left and also above. So 1 and 5 would be a corresponding angle pair. Another corresponding angle pair could be something like if I pick 3, that is on the right side of the transversal and under the line. So down here, I need to be on the right side and under the line. So 3 and 7 would be another corresponding angle pair. We could also do 4 and 8 because they are both below and to the left. And then I don't know if I have another color. Oh yeah, here we go. 2 and 6 would be our last corresponding angle pair because they are both to the right and above. Okay. So if you notice, for alternate exterior, alternate interior, and same side interior and same side exterior, there are 2 pairs of each of those. I have 4 pairs of corresponding angles though, so that's a thing. Okay, let's take a look inside here. I think I'm gonna do these with you in class. I'm making up my mind right now. We're gonna do these together in class. So we'll say that. Alrighty. Good luck on your homework. I know it's gonna be a little bit of a struggle, but that's okay. We'll go through it.